The lesson topic for this video is writing equations for linear story problems. So of course, sometimes we call story problems word problems. That is what we are going to be working on in this lesson, and we will do a lot of practice with this in class as well. So first of all, I want to remind you that we have three forms for linear equations, and we're going to write our equations in one of those three forms for each story problem. Again, we have slope-intercept form, or y equals mx plus b. We have point-slope form, which is y minus y1 equals m times x minus x1. And we have standard form, which is ax plus by equals c. I'm going to run through the key thing or things you want to look for in a word problem so that it can help you decide which form to use. I highly recommend that this chart in front of you is in your notes and that the tips I give you under these colorful rectangles is included in your notes, because you're going to look at some word problems in practice, and you're going to want to use this to assist you as you begin this topic. So first of all, if an equation gives you a starting amount, and if there is a rate of change, you will be using slope-intercept form. Now let's break that down a little bit. So if we have y equals mx plus b, m is our slope and b is our y-intercept. And if you can picture on a graph that our y-intercept is typically this place where we're starting, where x is 0. So if there's an original amount or a starting amount in a problem, so let's say it said a student has $500 in his checking account. Okay, that's a starting amount typically in a problem, and you'll hear that kind of thing in examples. The other thing to look for is a rate of change. So that's an amount that's being added or subtracted over and over. So again, with that same student with some money in his checking account example, it might be, and they gain $20 each week for allowance. So if that's a rate of change, you'd be getting $20 this week and $20 next week and $20 the next week. So that would be an amount being added over and over. So if you see those types of things, that is going to be key information to help you decide that slope-intercept would be the right equation to use. All right. So the next one, if you have two ordered pairs that are listed in one way or another in an example, or in other words, two data points, you are going to use point-slope form. What's going to happen is you'll have two ordered pairs, and we know that ordered pairs are x, y coordinate pairs, right? So let's say I have 3 100 and 2 1000. Okay, that would be two data points or two ordered pairs, and we will end up using the slope formula to help us write this one in point-slope form, where our slope goes here, and one of our 2 points that we have will go in for x1 and y1. And the third type, if you see two variables that are added to get a constant total, that is going to be a key piece of information to help you decide on standard form. An example of this might be if large beverages at a concession stand are $5 and small beverages are $3, and you sell 200 total beverages. You see how that was two variables and they were being added together to get a constant total. So the large ones plus the small ones were giving us a total number of beverages sold. And again, more practice on this, of course, not only in this video, but also in class. This chart will come in handy, so have it marked in your notes for you to refer back to while we are doing linear word problems. Okay, so now we're going to look at some examples of each of the types listed on the previous screen. You're going to refer back to that chart of information of how to decide which equation type to use for each example. I do recommend that you write this all in your notes to refer back to, but at least when you're going through them with me, write the equation type and the work for the equation for each example. All right, so example 1 says, a test was given that was worth 100 points. 5 points were deducted for each wrong answer. Now, if you think for a minute of what key information you are given in this problem, you'll notice that we have 5 points deducted for each wrong answer. All right, well, that sounds an awful lot like a number being added or subtracted over and over. That's like a rate of change. And the example in your chart that uses rate of change is slope-intercept. Now, it also says that the test was worth 100 points. So if you think about that, what we're thinking about here is a starting amount, right? The test starts with 100 points, and then 5 points were deducted for each wrong answer. So this is pretty clearly an example of the type of slope-intercept. Okay, the slope and the y-intercept are both kind of given in the directions. So what is the slope? Well, m is our slope, and in this case, a lot of people will write that the slope is 5. Well, you're close, but if 5 points are being deducted, our slope is actually -5. Our y-intercept is our original amount, so that is 100. So when we write this equation in slope-intercept form, we're going to have y equals -5 x plus 100. The second example says general admission tickets to a high school game cost $7 and student tickets cost $4. $11,200 worth of tickets were sold for the game. All right, so what we should see here is that we've got a couple of different amounts that are adding up to a total. Okay, we've got $7 per general admission ticket, and we've got $4 per student ticket, and all together that is going to add up to $11,200. So we have a total, we have two things adding up to that total. So what example or what equation type would that be? Well, that would be standard. The way we would write this equation is that it is $7 for every general admission ticket, and let's have general admission tickets represented by the variable x because we don't know how many of those we sold. So $7 for each general admission ticket, plus we take in $4 for every student ticket, so 4 times y, is equal to the total number of dollars that were taken in at the game. So standard form does look like this, ax plus by equals c. So that's why this is the form that works nicely when we know two amounts that are being added together to get a constant total. So you might guess that the third example here is an example of point-slope form, and you're right, but let's read through it and make sure we understand why. It says, when you started driving, you had 15 gallons of gas in your car. After driving for 140 miles, you had 10 gallons left. All right. Well, you know it has 15 gallons right here at one point in your tank, and 10 gallons a little bit later. And sometimes people think, oh, that's two things being added together to get a total. But no, it's not, because we're not going to add 15 gallons plus 10, because we had 15 and we lost some to get to 10. Plus, we don't have a standard total to equal that out to. But what you notice maybe is that we have gallons, and then we've got miles over here as well. But we don't have miles written down twice, and that's because it says right here, when you started driving. When you started driving, how many miles have you gone already? Well, 0. So after driving for 0 miles, you have 15 gallons of gas, and then after driving 140 miles, you have 10 gallons of gas. That is an example where you have two data points. So that is the type that we're going to use point-slope form for. If you remember and you look at that chart, it says for point-slope form, I recommend that you write out two data points right away. So one would be after 0 miles, you have 15 gallons of gas, and the second one after 140 miles, you have 10 gallons of gas. So how would we write our equation? Well, just like we've been practicing in class, writing point-slope form, the first thing we need to do is find our slope. I'm going to go over here and write m equals, and I'm going to use my y2 minus y1 in the numerator and x2 minus x1 in the denominator. So 10 minus 15 over 140 minus 0. 10 minus 15 is negative 5. 140 minus 0 is 140. This can be simplified into negative 1 over 28. So our slope is down 1, right 28. And you see that the numerator is 10 and 15 here for the slope, so that's your gallons. So you lose 1 gallon after driving 28 miles. Again, remember, we haven't written the entire equation yet. We have only found the slope. So I'm going to use this space right here to write my equation for this one. I apologize, it got a little squished over here. So I'm going to write in point slope form. I'm going to write y, and then I've got to pick one of these 2 points to use. I'm going to use this one here. So here's my y value, positive 10. So I'm going to write y minus 10 equals negative 1 over 28. And then x, and our x1 value is 140, so minus 140. All right, so if you look through, again, that chart with the 3 types and what information was needed in order to write the equation in that form, you'll see that we used that information, starting amount and a constant rate of change here for slope-intercept. We had 2 amounts that added up to a constant total for standard. And for the third type, for point slope, we had 2 data points that helped us write our equation in point slope form.